everyone, this is Chair Angabawa from Bachelor of Secondary Education, major in Science, and today I will share some ideas about physics. And in physics, we have the matter-wave duality hypothesis, which was proposed by Louis de Broglie during 1973. And in this hypothesis, Louis de Broglie states that all matter possesses its wave nature and particle nature. But somehow, this hypothesis is said to be lack of evidences. But in physics, they study about the three evidences that supports the hypothesis which was proposed by de Broglie that could said to be fact. The first experiment was the nickel crystal experiment by Davisson and Germer, and the next one was a double slit experiment which was proposed by Thomas Young. And the last experiment that supports the hypothesis of Louis de Broglie was the gold foil experiment which was proposed by Rutherford. So, in this video, we will tackle about what was inside those experiments.
Displayed here is a block diagram of the experimental setup used by Davisson and Germer. It consisted of a nickel fluoride crystal, the target, an electron gun, G, and a detector. The electron gun produced a beam of electrons. The electron gun used by them consisted of a tungsten filament, F, and high and low tension batteries. The low tension battery was used to heat the filament. The red hot filament produced an electron beam. A high tension battery was provided to accelerate the electron beam. The detector or the electron collector moved on a graduated circular scale. A sensitive galvanometer was also connected to the detector. How did they perform the experiment?
Another experiment, we have the double slit experiment which was proposed by Thomas Young. In this experiment, an electron was being fired into a two narrow slits. And this experiment serves as same as the diffraction of wave. And this experiment also supports the wave behavior and nature of electrons. So I will show you how this was being done.
This modern version is what we are typically referring to when we talk about the double slit experiment. From this, it was shown that a beam of electrons exhibits diffraction and interference patterns, just like light does. This demonstrates the wave-like properties of electrons, and by extension, matter in general. Later, low-intensity experiments showed that even an individual electron, when passing through biprisms or slits, will interfere with itself, making the wave-like nature of the electron undeniable.
So, in this last part of the video, we were going to talk about the last evidence that supports the matter-wave duality hypothesis of Louis de Broglie. In this experiment, this was proposed by Budd Rutherford, which we call the thin gold foil experiment. In this experiment, an electron was beamed into a thin gold foil and causes diffraction and interference pattern. This also supports the wave behavior and nature of electrons. So this is how it was being done.
Rutherford experiment. In 1911, Lord Ernest Rutherford performed an experiment which leads to the discovery of nucleus. The setup used in the experiment is shown here. A radioactive source was placed in a lead block with a narrow opening. The radioactive source is rich in alpha particles. These alpha particles are allowed to pass through the narrow opening. A lead sheet with a slit is placed just after the lead box. These fast-moving alpha particles passes through the slit and hit a thin gold foil. The alpha particles were detected using a zinc-coated fluorescent screen. When the alpha particles strike the fluorescent screen, they produce scintillations. This experiment, Rutherford observed that 1. Most of the alpha particles passed through the gold foil undeflected. 2. Some alpha particles were deflected at small angles. 3. Some alpha particles were deflected at large angles. 4. Very few of them bounced back at an angle of 180 degrees.
I hope that you like this video. Thanks for watching!